Hello, everybody, and welcome to our first lesson in Unit 3 on parallel lines. Today we will talk about pairs of lines and angles, and our objectives will be to identify relationships between lines, and we will also be able to identify angles formed by transversals. Let's first review some concepts, some new ones and some that we already know. Parallel lines. Parallel lines are lines that do not intersect. In other words, they continue until eternity next to each other, but they never intersect. Skew lines are also lines that do not intersect. Now, where are skew lines and parallel lines different? Parallel lines are in the same plane. They are in the same plane. Skew lines are in different planes. This is kind of difficult to imagine just like that. We have to think three-dimensionally. We have to think about a three-dimensional space. So let's look at this drawing over here. Let's look at this cube here. And here we have line AB. And now, which line or lines are parallel to AB? Well, we see line CD, and line CD is parallel to AB. And as you can see, they're on the same plane, which is essentially the top of our cube. But we also have another line, GH. GH is also parallel to AB. They will never intersect, and they are also on the same plane together. In this case, the plane that they share is the right side of our cube. So GH and CD are both parallel lines to AB. And note that they're not necessarily all three on the same plane. That's not what we're saying. But AB is on the same plane with CD, and AB is also on the same plane with GH. Now, which lines are skewed to AB? Skew, we said, have to be lines that do not intersect, and they are in different planes. Now, for example, I have this line down here, EH. This line will never intersect with AB. They're on different planes, so that is a skew line to AB. And we can keep looking, and we will also find, for example, the line back here, CF. CF is also a skew line to AB. Let me not forget that arrow going in both directions here. Both lines, EH and CF, go in different directions, and they are on different planes, but they will never intersect with AB. And when we looked at CD and GH, those were going in the same directions as AB. So let's go back to our notes and note that down. Parallel lines, although they will never intersect, go in the same direction. But skew lines go in different directions. That's how we make that distinction between parallel lines and skew lines. Now let's remember perpendicular lines. Perpendicular lines are lines that intersect at a right angle. And this symbol here is the one we're using for angles. And let's also remember that a right angle means that it's an angle with 90 degrees. Let's look about parallel planes. We talked about parallel lines. Parallel lines are lines that do not intersect. Parallel planes are planes that do not intersect. But they also go in the same direction. We could imagine a little drawing like this. Usually we draw planes like little squares or rectangles, even though, remember, they're not really confined like that. Planes continue until infinity. And here I'm drawing for you two planes. One is behind the other one. That's what that dashed line is for. And they go in the same direction, and because they go in the same direction, they will never intersect. We talked about the symbol for angles, that symbol that you saw down there for perpendicular lines. Also, let's review and remember the symbols we use for parallel lines and for perpendicular lines. Parallel lines use that symbol, which you can also see mirrored in the actual word parallel. Two lines right next to each other, technically two segments. And for perpendicular lines, the symbol goes like this, where you can see that the lines intersect at a 90-degree angle. Let's go back to our drawing and determine which lines are perpendicular to AB. Well, one line that is definitely perpendicular to AB is the line AD, going across here, and as you can see from this symbol, they intersect at a right angle. So AD is perpendicular to AB. And another one that's also perpendicular to AB is back here, the line BG. As this is a cube, we know that this is also a right angle. So BG is another perpendicular line. Let's talk about planes. Planes that are parallel to ABC. First of all, which plane is actually ABC? Plane ABC is the one above here. In other words, the top of the box, top of our cube. This one is the plane ABC. And the plane that is parallel to this one that we can see in this drawing is down here, the plane EFG. Those two planes are parallel. This leads us to two very useful postulates. The parallel postulate states, given a line and a point not on that line, there is exactly one line through the point that will be parallel to the given line. In other words, let's just imagine we have a line right here and a point that is not on that line. Now I can, of course, draw many other lines that go through that point, like this one or this one. but there's only one line that actually is parallel to the given line and also goes through this point. This is a pretty straightforward thought, and that's why it's called a postulate. Postulates are things that are being accepted without proof. The second postulate that we need to know and understand is the perpendicular postulate. And the perpendicular postulate states, given a line and a point not on that line, so starting the exact same way, there is exactly one line through that point that will be perpendicular to the given line. So essentially it's exactly the same thing, but now we're talking about perpendicular. And again, let's imagine this one line here and a point that we have. Again, we can draw many, many lines that go through that point, but only one of those lines will be perpendicular to the given line and cross it at an angle that is 90 degrees. Well, so much for the first part. Now go ahead and watch the second part of this tutorial.